Good morning, everyone. I'd like to present my PhD topic on the role of paternal age as a risk factor on the occurrence of congenital anomalies. My name is Hanna. I work as a resident doctor at the obstetrics at the Department of Obstetrics and Gynecology clinic at Semmelweis University. My supervisors are Nándor Ács and János Gidai. My SMS is Isabel Amorim. My statistician is Mikolt Bakony. My vision is to provide better antenatal care and higher quality of life for the newborns. And my mission is to provide evidence on optimal paternal age for having children. Currently, I have two ongoing projects. The first one has the work title of Investigating the Influence of Paternal Age on the Development of Congenital Anomalies via a systematic review and meta-analysis on a worldwide level. And in my second project, on a national level, by working on a population-based study. In my first project, I'm working with Leila Tigárgár. Overall, 2 to 4% of live births involve congenital anomalies, causing significant medical, surgical, cosmetic, or lifestyle consequences. And there is an increasing number of fathers at the age of 40 or more. But not only advanced paternal age, but also low paternal age can be associated with increased incidence of congenital anomalies. And currently, there is no consensus on the optimal paternal age for having children. So my aim is to investigate the association between paternal age groups and the incidence of congenital anomalies. My clinical question is, are there paternal age groups with an increased incidence of congenital anomalies? My population is the newborns, and I compare different age groups of the fathers. And I am looking for congenital anomalies, especially structural ones like circulatory defects, neural tube defects. My hypothesis is that there are paternal age groups that increase the incidence of congenital anomalies in the newborns. I've carried out a systematic search in 3 comprehensive databases, and we came up with almost 10,000 hits at the end of November last year. After finishing the duplicate removal, the title and abstract selection, we came up with 34 eligible full texts. And I had to make smaller groups out of these 43 studies. I call the similars those studies that worked with the same age groups, the same reference age group, and with logistic regression as a statistical model. I have also non-similar studies which had totally different age groups and various statistical models, and case control studies which were again totally different. It was important for me to make a comprehensive statistical result. After finishing the data extraction, I found that many very similar malformations were named differently, so I made subgroups according to this. And out of these 7 studies, I had more than 100,000 cases and more than 14 million controls. And I've already finished the analysis on 3 subgroups, 3 malformation subgroups, as it's visible on this slide. And I still have to go on with the rest. In the next 3 upcoming figures, I'd like to introduce you my results so far. On this slide, the occurrence of cardiovascular malformations is visible in the newborns of the fathers with advanced age compared with the reference age group. I didn't come up with a significant result on this slide. On this plot, the younger father's age were compared with the reference age group at the central nervous system malformations in the newborns. Again, we didn't came out with any significant results. And on my last plot, there you can see the occurrence of craniofacial malformations in the newborns of father with advanced age compared with reference age group. It's visible that in the advanced age group, it's 22% more likely to receive craniofacial malformation, and it means that it's both statistically significant and clinically relevant. The strengths and limitations. I think that during this whole process, the strengths were that the incidence of craniofacial malformation correlated with the available literature, and they've also had high number of cases and controls. And the limitations were that, unfortunately, because of the different age categories, we had to exclude many studies, and again, we came up with inconsistent categorization of the outcomes. So my conclusion so far is that advanced paternal age is significantly associated with higher odds of craniofacial malformations, and according to current status, cardiovascular in advanced age and central nervous system malformations in younger age had non-significant p-values. So my implication for the practice would be to specify screening in certain age groups and optimization of the family planning. And the implication for the research would be to lower the incidence of congenital anomalies by studying biological backgrounds. I've also managed to do the risk of bias assessment through the QUIPS method, and overall I can say that we came up with low risk of bias. So to sum up my first project, this is my progress so far. We are looking forward to finalize the figures and tables in the upcoming weeks. And let me talk a little bit about my second project. It has the work title of Investigating the Influence of Paternal Age on the Development of Congenital Anomalies in the Hungarian Population between 1980 and 2009. Just like worldwide, in 2021, in Hungary, 4.5% of live births involve congenital anomalies. And we've seen that by 2016, only half of the fathers had their first child under the age of 25, like in 2000. And 5% of the fathers were at the age of 45 or more at the birth of their first child in 2016. The age of the fathers at the birth of their first child increases according to this, and still there is no consensus on the optimal paternal age for having children. So my aim is to identify high-risk paternal age groups in the Hungarian population for congenital anomalies. My clinical question is, are there paternal age groups with an increased incidence of congenital anomalies? And we are working with a very similar PEO framework, just like in my first meta-analysis. My hypothesis is that there are paternal age groups that increase the incidence of congenital anomalies in the newborns, and my clinical implication would be to increase childbearing awareness and lower the incidence of congenital anomalies. I'd like to introduce my study design as well. Our data are going to be collected from the Hungarian Case Control Surveillance of Congenital Anomalies, which is a very special database which has very detailed data about the pregnancies. And as a control group, we are using the Hungarian Central Statistical Office registrations. The study period is between 1980 and 2009, and during this study period, there were more than 30,000 cases with birth defects in comparison with the more than 3 million live births in Hungary. So to sum up, I'm planning to finish both of my projects in the next month. And I'd like to finish my slides with one of my favorite quotes from Kurt Vonnegut: "Science is magic that works." Thank you for your attention.
Thank you. Thank you, Hanna. This nice presentation. Questions, please.
Hi, Hanna. Thanks for your presentation. So my question is, as far as I know, you just involved seven studies, yes, with a similar age groups,
yes,
involved in your meta-analysis. My question is, for those studies, they don't have the consensus reference. For example, the 25 to 29 for the father's age. So
you mean the other studies that I've excluded?
Yeah.
Yeah, there were totally different age groups for the reference as well. Yes.
Yeah. So I would like to know, how do you do the analysis based on these studies? For example, the case control studies, will you put the results together with maybe the cohort studies or any other?
So far, we've excluded all the studies that didn't work with the same reference age groups and control age groups.
Oh, so you just abandoned to analyze them, right?
Yes, yes. So I only did it with the 7 studies that were similar according to the results, the reference age groups, and the statistical model.
Okay, I got it.
I was wondering about your second project. How long is the follow-up time on that one?
On this in the second project, it was 3 months.
Thank you so much.
Congrats, very good presentation. I had a question from the first project. So, were any confounding factor being taken under consideration that could possibly affect to cause these congenital formations?
Thank you for your question. Well, there are confounding factors, just like the mother age, the smoking, but we are trying to exclude these and only concentrate on the paternal age. So we are limited to this in this whole procedure.
I have a question. Regarding the studies that were not meta-analyzed, how do you plan on presenting the results of them as well? Because they are also clinically relevant.
Yeah, thank you for your question. That's a very great question. We are working really hard with my statisticians to solve this problem currently. Yeah, thank you.
I saw that you have only the youngest age group was above 20. But in the results that you couldn't pull because they didn't have the same reference group, did you find some data even for the younger fathers?
Yes, the 3+ that you've seen, well, there was one interpreted at the younger age because it was the central nervous system malformations, because according to the literature available, there were malformations more common at younger age groups, while, for example, the cardiovascular malformations, it was more often at advanced paternal age groups, so I only showed these. I have plots also for them, but to put an emphasis and to try to highlight the importance, I've only put there the central nervous system malformations because the only significant result was there.
And are there some possible reasons for this, why these young fathers have higher risk for these central nervous system malformations?
I can only mention the age of the fathers there.
Regarding your first topic, are you planning any subgroup analysis in terms of spontaneous pregnancy and pregnancies after IVF therapy?
We are not planning to separate these 2 groups.
Okay, thank you.
Thank you.